I'm Kinnera. We're going to talk about Android and Arduino. I came across it pretty randomly, so I think of it as a love connection. A little bit about me. Yeah, that's not working. A little bit about me. I studied to be an electrical engineer, so I still have a little bit of love left over for electronics. And I've been doing Android for about 6 years now. Yeah, I have a 3D printer of my own, so this construction here is entirely 3D printed and completely modular. And so I thought, what can I do with this that all mixes my love of electronics with a love for Android? And so this talk is going to be introductory. It's going to be about how we can connect Android to an Arduino, what we can do with it that's beyond what sort of normal electronics can do, in an easier way at least. So yeah, okay. So first thing we'll talk about why the tentacles. I'm sure a bunch of you are wondering what is wrong with me. So that's the first thing we'll talk about. The second thing is how to connect a USB device with Android. It doesn't have to be Arduino, it can be something else. It can be a USB accessory, another USB device. We can do a lot with all of them. Number 3, we'll talk about a little bit about the construction, the design process, and how I went through with designing and printing this. And then in the end, we're going to talk about the most important part, which is sending input from Android to the Arduino and then back. So from sensors back to Android, and then from Android to the Arduino. All right. First, why the tentacles? 2 years ago, I came across this really interesting robotics article that talked about how tentacle movements work in nature, right? Think of a constant length of string. We have an equal length on both sides. If we reduce one side, length on one side of the string, the other side increases, right? This is how it works. So we have the resistance to the longitudinal compression, and then we have an extension on the other side, which is how it works. This is how we form a C, right? If we wanted an S, we would need 2 of these. We would form one C and then another C, and then we get an S. So I was looking at this paper, which is really interesting, but I won't go too much into it. What it says is that we have a universal joint, right? So it's a linear guide, and then we have a spacer disc, and then we're giving those springs as tension. We're making sure it doesn't just flop around. We're giving it the tension to maintain its shape. And then, like I said, the first section, this can form a C, and then the second section can form another C, which makes us form multiple different shapes with this thing. Okay, so there was also another experiment that I read about. It's an open source robot that was created for surgical robotics research, and it was really interesting because this was 3 segmented, which means we can make a complete circle with this. And so with the kind of tension and pressure and all of the things that we do with this, we can do a lot of different things, and this is actual research, right? And so I thought, how can I make this easy? Something that I can make and something that relates to the things I know. All right, so we have segments, and then we have the servos that move these, right? So it's focusing on simplicity. And then once I read that, I thought, how can I do Android? And why Android? Number 1, when we're doing electronics, for the most part, we're using buttons or potentiometers to change whatever values we need to have custom values inside this. It's not just a binary on and off, right? Number 2, ease of debugging. With Android, you can see exactly where it went wrong, right? You can not just debug the Arduino, but also the input that you're providing from the user. Number 3, customization. Just imagine it, like, you know, when you have lights in your room and then you can change all the colors with Android apps. What if you could do this with complex electronics projects? You can make a UI that helps you change every single thing about the project. That just provides a wide range of opportunity. Then the first thing we'll talk about is how to connect a USB device with Android. It doesn't just apply to an Arduino, like I said, but we will look at it from the focus of an Arduino. Okay, the first thing we're going to do is add the user's feature, right? Because not all Android power devices are guaranteed to use a USB host. So we have to include this to make sure that our application uses this library. And then we want our application to be notified every time a USB device is connected, right? We don't want to open it and then say, oh, maybe I have a USB device. You want to make sure that you have a USB device. So what this action here does, with the metadata, is to look at the device filter, see if any of these particular devices are connected to our Android, and then open the app if we do. So In the USB device filter, what do we have? We have an XML file that we open in our XML resource directory, and then we mention vendor ID. You can also mention product ID, a class, a subclass, a protocol, pretty much a wide range of things. Or you don't need to mention anything at all, and then you can see what you have, right? Okay. Next, what are we going to do? We are going to initialize a USB manager. This is the manager that we retrieve from the system service. We're not really creating it. And then we're going to get the USB device we need. So our manager provides all the devices that are connected to your USB port, right? And then we're going to get it. It's a very big object. It has all of the information you need. But here, the vendor ID for Arduino, the standard version at least, is 9025. So that's what we're going to look at. If you have any cheaper versions of it, you might want to look at what vendor ID it has. Okay, so we have our USB manager and we have the device. So now we're going to request USB permission. Of course, if you give a wide range of USB permissions already, you don't need to do this. But always a good thing to request user permission, especially now with Android, so I would recommend it. Next thing we're going to do is find the interface. Most USB devices have multiple interfaces, and you can use any of them. It's just basically a pathway for your device your host to connect with the device. So here, let's say we pick 0, right? And then we have to figure out which one is the in endpoint and which one's the out endpoint. Here we're assuming 0 and 1, but we shouldn't be assuming, right? We should be able to find out which endpoint is the input endpoint and which endpoint is the output endpoint. How do we do this? With Android, it becomes really easy because we're just going to iterate through all the endpoints, and then we know we want to transfer data. So we're going to look at the type that is the transfer endpoint, right? And then we also get the direction. So if it's an in direction that we're looking at, we're going to say, okay, this is an in endpoint, an out endpoint. And so we're going to save this, much better than guessing what it's going to do, right? So in case of bulk transfer, we need this because especially when we have input coming in from the Arduino, a byte buffer is going to be filled in, and then we're going to keep resetting the byte buffer. So this means that we need a continuous stream of data. We want a large transfer here. Yeah, so we have a bunch of USB constants, again, for a bunch of different things. You can always look into it. But this is the simplest part of it. Okay, so we have our in endpoints, out endpoints. We have a manager. We have our device. We're going to connect the device to the USB now. Okay, so now with the manager, we're going to open the device and then claim an interface that we talked about earlier. So this interface has the endpoints that we need to send the data to and from Android. Okay. Next part, this is interesting, a little complicated, but interesting, because first we need to reset this interface pathway, right? So we're going to say we need to give it specific parameters to reset it. And there are a bunch of things. This is Java, which is why they're all commented out. But what does 0x21, 0x22, what does this mean? This is all hexadecimal, right? And the interesting part about this is that you don't need to wonder what it means. It has 3 specific paths, right? The first thing of this is the direction. So we're going from Android to the device. That's the first part of it. The second part of it is telling us that it's a class-specific request, right? And the third part, the one part, is telling us that this is to an interface. So this is a class-specific request directed towards an interface, telling it to reset it, right? So the 0x22, that's the request that we have here. It's basically clearing the control lines, right? So we're making sure that the hardware data flow happens correctly. Okay, the next thing that we do is setting the baud rate, because what does baud rate mean? It's basically how many bits per second are being sent across from a device to the other device, right? We will talk a little more about the baud rate later, but here we are also setting like stop bits, parity, data bits, not things that you really need to worry about usually, but if you have something specific to do, this is where you set it in Android. So you know exactly what you're setting. You don't need to worry about a bunch of different things. Okay, so we have our USB manager, we've reset it. Now we have our connection, we're going to register a receiver, right? Which is pretty similar to how we do usual receiver. This is a broadcast receiver here. That's what the USB is doing. So we're going to add these actions, right? So we are going to add these actions to the intent filter so that it listens to the USB device. So we have the attached one, detached one, and then we register it. Okay, so Now in the callback, we're going to use the broadcast receiver to handle these events. And of course, in onDestroy, you have to handle how the connection gets destroyed. Okay, so there are libraries already that are really good. The first one is very comprehensive, has a really wide range of devices. I would recommend it if you were looking for something more complicated. The second one is very Arduino weight, very lightweight. You can use this. The reason I mentioned all of the connection is because it's easier to debug when you know what exactly you're doing. It's very easy to run into a bunch of errors with Arduino, especially because the connection isn't always stable. There are errors that are very hazy, very vague. So you have no idea what's going wrong until you know what's wrong. Okay, so we've talked about how to make the connection and why the tentacles, even if, yeah, I don't think I need an explanation for that. Okay, so I'm going to talk a little bit about how I went into this. So first, like I mentioned, this is the first paper that I did run into. So it talked about having a disk in between, and then we have the springs which are going to provide the tension so it maintains shape. And we need the universal joint in the center that provides a 360-degree motion, right? But it should not move in the z direction, only the x and y's. So how do we do this? First, I created a disk, something on par with that, right? So then it has the 4 holes on the side to run the disks, to have the springs, and then one in the center is a universal joint. So this is how it looks like. You can always look at it later. So there's the universal joint in the center, and then we have, this is one spacer disk set, and we have a bunch of these to make a length. I didn't make it too small because that will look questionable. But this was the first thing that I made. This has no electronics at all. So this was the first iteration of this. We have 2 pulleys. The X pulley makes sure it moves in a C in the X direction. The other one in the Y. So when we put those 2 together, it can move in a 180-degree plane, right? The next iteration that I did was a server-based one. So it had 2 of these, and then it did this. So it was very cute, but a bit bulky, and I wanted something that was more compact and looked really nice. Okay, so then I thought, okay, I need to make this longer. We talked about a single segment before, so I wanted to make it a double segment because then it can do more complicated, really pretty S motions, right? So for that, we needed 2 servos for the previous one, right? So we needed 4 holes. It runs through one end and then the other end. If I wanted an S, I needed 8. So same thing again. We have a universal joint in the center, and then it goes this way. Okay, so we have a bunch of them, and then now I made it more compact, right? And so I went with a really flat base. We need all of the servos in here, so I said, okay, let me have servo holders that hold it really tight, and then they can be screwed in. And then you add the servos in there, right? And then we have the pulleys that were all printed in, which needed to be printed in 2 parts because we need the space in the center, and a 3D printer is questionable with spaces that print on top. And then we have our screwed in holder, so it can hold the top, and then we have the top on top of that. So it has a spacer disk built in so that the rest of it can be connected directly to the base. Okay, so this was one of the first iterations that I did do, and it worked pretty well, but the pulleys were so small it didn't move much. So I thought, okay, let me make them slightly bigger. And so that's how I ended up with this. That's a lot about how the spacer disk was made, and the springs were actually something that I thought about a lot because I bought a big set of a lot of different springs, and I thought, okay, what would actually make sense? What kind of tension would it need to make sure it retained shape? It shouldn't be too loose, which means that it would just really spring back and forth. If it was too tight, it wouldn't move at all because these servos are really cheap and don't really do very well. So we want to make sure that it had a good amount of thickness. So it took a bit of iteration, and then, yes, so we have the strings running through the pulleys on 4 different sides. So the first 2 do C's in the 180-degree plane, and then the other 2 do C's in the next plane. Okay, so now the really interesting part, which is how do we send in, the data from Arduino to Android and back? We have our connection, we have our devices, we have made sure that they're both connected. Now how do we send the data? Okay, before we do something really complicated, we will start off with a very simple LED example. Let's say we just want it to blink, right? I'm not going to show that because I don't have it, but I have the code. The first thing we're going to do is use a byte buffer, right? For let's say 1, it's the command we're going to send to make sure that it blinks. That's an on, right? So we're going to convert it to a byte array and put it into a byte buffer, right? And first thing first though, we need to send it to the out endpoint. We have a connection and then we're sending it through to the other side. So we have to make sure that we use the out endpoint that we found earlier, right? We went through and found the direction and the type and we said, okay, this is the out endpoint. So we have this saved in our activity. And then we're going to use the same thing to use at the out endpoint, right? And then again, we don't want to run on the main thread. We want to make sure it's on the I/O. We don't want to block the main thread, don't want to freeze anything, which can happen, especially because this is a long-running process and very time-consuming. If you would accidentally run into a loop, you're just stuck, and then you have no idea what's happening. So it's a very good thing to run on the background thread. Okay, so what does this do? The byte buffer here is going to queue the data for us so that we can send it, and then this is compatible with like native USB communication. So that's what this is going to do. That's why we're using a byte buffer in the first place. So any information you have, you will always send it through the byte buffer. Okay, so first we're going to initialize the request, right? And then in the highlighted area, we're going to queue this byte buffer. So we're going to say we'll put it into the queue for the USB device. We don't know if it's done yet. We don't know if it will do it. We're just going to queue it. And then if it didn't, then we can always say it failed to queue, right? So the way that we handle error messages here is really important because it provides us every single step. So once we've queued it, we know that it's queued. Then we're going to wait for it to see if the queue is successful, right? So it waits for the request to complete, the connection.request wait, and then we're going to check that the request we sent is the request it executed, because it might have something else in the queue, right? It could have something else that it is doing from some time past. We don't know. So we're going to check if the command is the correct one we sent, and we say, okay, this has been sent. Now, we're going to check if Arduino will do this. How does it do it? This is where the baud rate comes into the picture, right? So we're going to set up our Arduino. How many people here have worked with an Arduino before? Yes. Okay. So serial on Arduino? Yes? Okay. So to set up a serial, what are we going to do? We're going to send the baud rate to the, we're going to set up a baud rate, right? And then this tells the Arduino to get ready to exchange messages with the serial monitor. In our case, it's going to be the Android, right? So that's 9600 binary ones and zeros, and it's called a baud rate. This is going to be per second. For example, this is normal for an Arduino, but if you're using an Arduino Mega, for example, it has serial ports with different baud rates. It can be 11,960 something. So depending on what kind of device you're using, you might want to check your manual or what kind of baud rate it employs. Okay. So next thing we're going to do is check if the serial has any available data, right? So if it has that data, we're going to read it. Now this read can only read one character at a time, which is good in this case because we have the 1, and then we'll say, okay, if it's a 1, we're going to glow the bulb, and otherwise no, right? So this is perfect. Reading here is always easier than sending. Sending is always going to be the hardest part, no matter if you're sending from an Arduino or the Android. But reading is always easy. Okay, so we have a serial class in an Arduino, which is based on the stream base class. So what does this have? It's going to check if it's available. It can read, find, read bytes until, and read string until are really, really good because you can't just keep reading one character. I mean, you can with a for loop. Not fun to write for Arduino, but this will be much easier. Stream really defines all of the reading functions in Arduino. So any core functionality that you use that has a read will use this. Like serial, for example, wire or Ethernet, any kind of Wi-Fi, all of them use the stream base class. So you can always use this no matter which way of communication you're using with the Arduino. Okay, so for the servo, which is what we're using here, we're going to talk about what we do on Android. Now I'm going to do a really simple example, and then I'll show you what I did. Okay, the first thing, just use a normal outline text field and compose, right? I'm going to have a remember mutable state of for the server angle that I will enter, and then I'm going to send it back in the callback called onMoveServoClick. So let's think of it like this. We'll ignore everything on the top. We just have the outline text field, right, with the servo angle, and then we're going to send it. So what are we doing here? In the callback that we have called onMoveServoClick, first we'll check if it's connected, because we have that information already from when we made the connection and have the device and checked out the endpoints. And we're going to do something similar to what we did with LED blink, right? We took the servo angle, we converted it to a byte array, and then we put it into a byte buffer. So this byte buffer is queued now. We initialize the connection with the same out endpoint, and then we're going to queue it in again with the same byte buffer, wait for the connection, check if the request is the same one that we sent, and so it's sent. Now we need the Arduino to receive the same servo angle and say, okay, I got the same one. So here we're going to use read string until, which is why I mentioned it. What this is going to do if you send a bigger number like 90, 100, even though this takes only until 180 because it's a servo, we're going to read it, and then we're going to check for what number it is. Of course, the easiest way to move a servo is to just say write, and then it would move in a questionable number of time. You don't know how much, and if it's too much, it will just fly across the room. Do not try it. So that will happen. So what we're going to do is put in a for loop and move it step by step, right? So we're going to give it 15 milliseconds, which is really small amount of time in the scheme of things. It will move in under a second or two. Okay. So how do we receive data on Android? We've sent it. Actually, before we do that, I will show you how this works. Hopefully it works. Okay. So this is the same app as that one. So I'm not fooling you. And let's see. Does it move? Oh yeah, one of them moves. Two of them move. Can everybody see? Oops. Okay. That one's marking much better. Okay. You're always welcome to try it out by yourself. Later, we can do multiple different numbers. It's going to move in different directions. It has all of the U-shape and S-shape capabilities that we were talking about. You can also change which part of it is moving. So you want the bottom to move in a C, the up to turn in an S. They're all going to move in completely different directions. So you can really make sure which part of it is moving. I think the next thing that I would definitely like to do is to see how much of space it can map, in the sense that I move it in different directions and be able to do it in maybe a movement curve, like a color circle, for example, where it goes in different directions and I can just make it go in the space wherever I want, right? Which is possible with Android, because I can just have a compose drag and drop facility, or I can just have a something with on touch, and so that makes it really easy for me to be able to do this on Android, right? That's the best part of it. Okay. Yeah, it's fine. Okay. Yeah, I think there's some left over. I did not do that. It did it all by itself. Okay. Yeah, you're welcome to try it out after the talk. Next thing we're going to talk about is how to receive data on Android, which is just as cool, right? What if I had a sensor on top of this that moved every time I walked across it? Home decor idea, right? That's the plan. I want to have like 6 big tentacles on the wall, and then it moves every time I walk across. I won't feel alone anymore. So that's the plan. There are so many different things that we can do with this. So one of the first projects that I did that received data from Android is this sensor on my 3D printer. So my 3D printer is super basic, and it does not tell me when it finishes a print. It just finishes and then chills, right? So I really want to know when it's done. So what I did was, every time a 3D print finishes, the nozzle moves to the end of the line and then waits there. So I need to find out when it's there for an extended period of time. That's when it's done. What would I do? So the first thing we do is we want to read the data on Android first, right? So the Arduino sends us like a bunch of information. It's basically sensor data across every couple of milliseconds. It's just like, oh yeah, you're 23, 24 millimeter away from me. So it's really, really precise. And I don't really need that much information. So I'm going to take the average of all the sensor information that we have. The most important thing about working with sensors on Arduino is to make sure you sample your data really well. When you have so much influx of data, it's really easy to go, I can do so much with this data, and that is true, but you also have to make sure you get exactly the information you need, and that's the hardest part in the Arduino world, right? So in this case, for example, again, we have the in endpoint, something that we found before, and then I'm going to take the last 5 readings that I got from the sensor and say, if the last 5 readings are the same, then it's close enough for me, right? So I'm going to go with that and then say, okay, if it's not close, I want to clear the byte buffer. I want to make sure that the new input that's coming in has place to be filled in. So I'm going to check if it's not close enough. I'm going to queue the byte buffer again and then check if the request, right? If it's not close enough, I won't do anything. And if it has remaining space in the byte buffer, I will just let it go because it can still fill up, right? But if it does not have any remaining space, I will clear this byte buffer, which is why in the beginning, if you look at the first line, we took the max packet size by 2. So we took that really big array and allowed it to be filled in by the Arduino. So this is what we're doing here. Now, when it's close enough, you open Spotify. Yeah, I had a really weird song on there, so now it doesn't link to anything. But it works. So that's what we're looking at doing. So we have our Android, right? We took the data, we sampled it, we looked at the last 5 readings, but on Android, I didn't do a bunch of it. Here, I'm doing a lot more sampling, right? So first of all, I'm going to check the distance, right? I'm going to see how far it is from my sensor, and then set up a control distance, right? Which is I'm going to first let it be in the same position for a really long time, take a lot of samples, and see what my control data is. And okay, that went by really fast. We're going to take a filter array here. Again, same thing. I'm going to take 20 samples in a really small amount of time, and then add all of my measuring to that data, to that array. So I have a lot of arrays here, and then I'm going to take the average of 5 to 15. I know this is kind of weird, but the first 5 and the last 5, I'm just disregarding them. So I'm taking the middle 10, and then I'm getting the average of it, which is giving me a good amount of distance for that entire length of time. So it's the average that I need. And so using this is what I'm going to send back to my serial, right? So that's what the serial.print is doing. It's going to print into the serial, which is what Android is receiving. So we're doing the same thing again. We're giving in the baud rate, beginning it, so it's connecting to the serial monitor, and then sending all of the data that I receive from the Arduino to the Android. Okay, so this is how it worked. Next steps that I have, number 1, Arduino with Wi-Fi. I mean, I had it already, but I did not want to jinx this. This was already quite jinxed with the demo. But that's the best way to do it. You can be far away and then control it with your Android. Of course, this is the best way to do it. Number 2, suckers. It doesn't really look like a tentacle, so it's just a purely aesthetic choice to add suckers to it. Number 3, we have, I also 3D print on fabric. You can 3D print on mesh, which is really interesting because the way 3D printing works is that it prints layer by layer, and you have mesh in between. What happens is the plastic on the bottom fuses to the plastic on the next layer, and so the mesh gets stuck in the middle, and so you can print on fabric. I have a really cute dress with cats on it that I printed. Happy to show it to you if you want to talk to me later. But I also want to make sure that that is something I can do with this, because then it makes the aesthetic choices way nicer. And so that's something I want to try out. Number 4 would be more segments. Right now it can only do an S, but if we go up to 3, maybe 4 segments beyond that, I don't think it can bear the weight. Maybe more heavy duty servos would work really well, something more expensive. So yes, I'm happy to try that out. Most important thing is compose. I want to do more with compose, see how much more data I can send through to the Arduino, or how much more data I can get through, and show it in a more visually appealing way that I can work with. Okay, so just one last thing before we end. We talked about this. one segment can make a C, right? Two segments can make an S. Okay, so I have a question. If you get it right, if you want, you can take some of the tentacles with you. I'm happy to give you instruction and do some troubleshooting. Okay, so I have this shape. How many segments would this take? Yes? It's a little tricky. First come, first serve, so 14? Okay. 6, okay. 7, okay, I have a 7. Any more numbers? So who said? Someone said a 5? Okay. 6, another 6, okay. 9? Okay. You're going down from a 14? Okay, all right. We have a 5, a 6, a 9, and any other numbers? Okay, the actual answer is 5. It's nice to, yeah, congratulations. If you want a tentacle, you're welcome to. No, I mean, I can print a lot of them. This took me to, yeah. The way this works is that we have the single length, which would be a 1. The curve below it would be a 2. The whole straight line is a 3. It doesn't require 2 of them. One other for the curve, and then one from the straight line again. So that would be a 5.
Ideally in mind, but I thought it's kind of a stretch. But
yeah, it worked. Yes. Great. This is the QR code for the presentation, so you're welcome to it. I don't have a files for the prints yet because I want to make it more stable before I let anyone try it out. But I'm happy to share it on LinkedIn or Twitter when I'm ready to do it, or maybe at a future DroidCon. So yeah, thank you so much.